Last class we have started with the implementation of the file systems, right? So in that implementing of the file system, we have seen the file system structure. So this is what the file system structure we have already studied in the last session. So I will just tell me once again this one. So this is contains the different layers. Okay, so we know the file is a collection of related information. So if you take that text file, then it will contain the text related information. If you take the C file, then it contains the C related information. Okay, so totally a file is a collection of related information. So generally all the file systems are stored in the secondary storage devices such as the hard disk. So we know that all the usually the file systems can be stored in the secondary storage devices. So we can perform the operations on the file which is stored on the hard disk in the efficient manner. So here first we know the definition of the file and where the file is be located. So and what is the operations, what are the different operations we are going to perform it on the file. So to make all the operations in the efficient manner, so in this following layer, so this is how the different layers we have following here. So based upon these operations, so like either if you want to read the file or if you want to write the file, or if I need to append some of the data at the file. So if I need to do all these operations, then I have to follow the following layers. Okay, so this is what the different layers. So why it is used the different layers? So if the any file, if we need to do the any operations on the file, then we have to follow these different layer. So we already studied that first one is the application program. So in that, what is the application program? The program which is developed by the user. So the whatever the program or code which is developed by the user, it is going to call it as an application program. So for example, if you want to take out the printout, so that is one of the application program. Like whatever, if you are want to require to take the printout, it is one of the application program. The application program is a file. The file, it is given as an input to the logical file system. So here application program is the first thing. So the user code, the user program which is written here, that is known as an application program here. Okay, so that is the name of the file. What is the user has written the code here. Okay, so that application program is a file. So this file is given as an input to this logical file system. So in this application program, so whatever the program of a file, it can be given as an input to this logical file system. So here the logical file system, it checks whether the file is present in the directory file structure or not. So what will happen in the logical file system? In their logical file system, it checks whether that particular file is present in the directory file structure or not. We know that what is the definition of the directory. Directory, it is used to organize the files. So in efficient manner, need to organize the files in the directory. So here the application program, the user program is given as an input to this logical file system. In the logical file system, it will going to check whether that particular file, whatever the file it is taken as an input here, that particular file, if it is present in the directory structure or not. So if the file is present in the directory structure, then it find the location of the particular file. So if that particular file is present in the directory structure, then what the logical system will do, it will check the location of that particular file. Let me take an example. F1 is the file. That F1 is given as an input to this logical file system. In that logical file system, it checks that particular location of the F1. If that F1 location is present here, so then that corresponding so for example, if F1 is present in the directory, like in the linear fashion, if that F1 file is present, then the corresponding whatever the location is to the F1 file is to be noted here. In which the location is corresponding, it is present also, it finds the logical block number. So once it is finded the location of that file, along with that location, it also finds the logical block number. So what is the logical block number? So that particular block we are accessing, whatever the block it is able to access by the user, that is known as a logical block number. Here what the logical file system will do, it will take the program as an input from the application program. It checks whether the file is present in the directory or not. If it is present, then it finds the location along with the logical block number. Okay, so that logical block number is given as an input to this file organization module. That logical block number is given as an input to this file organization module. So it is given as a file organization module. So in the logical block number, if you may look into it, like, so if you taken that logical block number, so it will be look like that. Okay, so there will be a different blocks are divided here. Okay, so for example, this is the first block and this is the second block up to so on. Okay, so this is how the logical block numbers can be differentiated here. So here the physical block number will specify the exact the block number in which the file is stored in the block. Here we are going to get the logical block number from the logical file system. That logical block number is given as an input to this file organization module. In addition to the logical block number, so the physical block number, it specifies the exact number in which the file is stored in the hard disk. So here we know that hard disk is organized in a several blocks, so and that each file is to be stored there. Okay, so next, this logical file system, it will accept the file names as the input and checks whether the file is present in the directory structure or not. If the file is present in the directory structure, then it will going to find the location. Along with the location, it will going to find the logical block number. That logical block number is given as an input to the file organization module. So that logical block number is given as an input to the file organization module. So in this file organization module, so this is a third layer. This file organization module, it accepts the logical block number as the input. So it accepts the logical block number as the input, and it performs the mapping or translation scheme. So it will going to perform the translation or mapping scheme. Okay, so in order to find the physical block number, so whatever the logical block number, it is taken as an input to this file organization module here. So it is taken as an input to the file organization. In this file organization module, so it will going to give the physical block number. It will going to find out the physical block number. So physical block number is nothing but where the file is exactly stored in the hard disk. So the task of the file organization module is to find the physical block number corresponding to the logical block number. So I will repeat once again. The main task, the main work of this file organization module is to generate or is to search the physical block number which is corresponding to the logical block number which is given as an input to this file organization module. So here the physical block number is given as an input to the basic file system. So now the file name is given as an input to this logical file system. So and again the logical number which is generated here, it is given as an input to this file organization module, and whatever the physical block number which is generated here, it is given as an input to this file system. That is what the basic file system. Now the basic file system, it issues a commands to the input output control. So once it receives the physical block number, then what the basic file system it will do, it will going to issue a command. Okay, so it will going to issue the command to the input output control. Okay, so one command is issued into this input output control with the help of block number. So how the commands will be look like? So for example, if the block number is equals to 1 2 3, then how the command is to be given from the basic file system to the input output control. So it is given like that: read 1 2 3, or it can be write 1 2 3. Okay, so these are the different commands which is given by the basic file system to the input output control. And in this input output control, we know that the different device drivers which is present in the input output control. So this input output control, it accepts the command which is going to send by the basic file system. So every hardware component in the computer, let me take any hardware component in the computer, it contains the different driver files. Okay, so it is the duty of the device driver file in order to communicate with the devices. What is the working phenomena, or what is the working task of this device driver. So that working task of the device driver in order to communicate with the devices, okay. To communicate with the different devices, it can be done by the device driver. So input output control, it contains the device driver. So this layer, what is the particular input control layer is that, so this layer, it contains the device driver file. So it will going to take the responsibility to communicate with the other devices, okay. So like if we need to read 1 2 3 into the file, okay, so this is the different following layers has to be taken. So if I need to read 1 2 3 into the disk, so then this device driver, it will going to help to make the communicate with the devices, then it will read the file. So again, if it wants to write the file, so again that's whatever the device drivers which is present in the input output control block, it can make a communicate with the device, and it will going to write the task into the input output control, okay. So this is what we have already discussed in the last class, okay. So that it is a file structure, or it is a file system structure, okay. So if any file systems are organized into the several layer, so to make all the operations in the efficient manner, so we know that what are the different operations, like either it can be read operation, or it can be write operation, or it can be append operation, or it can be delete operation. So the any of the operations, if I need to perform on the any of the file, then I need to follow this different layer mechanism, okay. So the next topic we are going to study, that is a file system implementation, okay. So next is the file system implementation. So in order to implement the file system, we have to use the two types of the structures here, okay. So if I need to implement any of the file, okay, so for example, if either it can be open a file, or it can be read a file, or it can be write a file. If I need to do anything on operations on the file, so there in order to implement the file system, we have two types of the structure, okay. So one is the on disk structure, and second one is the in memory structure, okay. So these are the two different of structures are implemented in the file system, okay. So one is the on disk structure, and second is the in memory structure. So in this on disk structure, okay, so these are the different parameters which is present here. So disk structure means, so these structures, okay, so what are these different structures are there, like boot control block, volume control block, and as well as the directory structure and file block. So these are known as a structures, okay. So these are the different structures which is present under the on disk structure. So what is the definition for on disk structure? On disk structure means, so these structures which are maintained in the secondary storage. So these different structures, if we are maintaining in the secondary storage, then we are going to call it as an on disk structure. So if in the memory structure, in memory structure means, so these structures are maintained in the main memory, okay. So these are the different structures which is maintained in the main memory. Here kernel memory, it is also known as an main memory. So here you have to know the difference between the on disk structure and as well as the in memory structure. So if these structures, if it is present in the secondary storage device, then it is a on disk structure. If these structures which is present in the kernel memory, that is the main memory, we are going to call it as a memory structure, okay. So we'll see that one by one, what is the definition for these different structure. So here the main memory is divided into two parts. So if you take the main memory, the each main memory is divided into two different parts. So one is the operating system, okay. So one is operating system and the kernel part. So in that operating system, it contains the important part of the code, okay. The important part of the code, it is present in the kernel. So the important part of the operating system which is resides in the main memory. So here it is divided into two parts, like as operating system and as well as the kernel system. So here, okay, so this is the diagram for the in-memory file system structure, okay. So in-memory file system structure, it is nothing but these are the different structure which is present in the main memory. So if you look into this, it is a main memory, so that we are going to call it as an in-memory structure, okay. So here first one. Okay, so this is we are going to call complete, it is an open file system function call, and second one it is to read a file. Okay, so these are the two different memory structures are there. So just to take down heading as a in memory file system structure, in memory file system structure. So there you make a note of these two diagrams. So first one is the file open and second one is the file read. Can you able to see this diagram? Yes, I am audible to you.
Yes, ma'am.
Can you able to see the diagram?
Yes, ma'am.
Yes, ma'am.
Make note of this. Okay, so before we are going to this diagram, so here first is the boot control block. Okay, so it contains the information that is needed to boot an operating system. So for example, if you need to boot the operating system, okay, so what is the code and what is the procedure to boot the operating system, that contains that entire information. It contains the information that is needed to boot an operating system. Generally, hard disk is divided into several partitions. We know that usually the hard disk, it can be divided into the several partitions, right? So in that partitions we known as an each partition we are going to call it is an each block control, that is a each boot block control. So this BCB, what stands for the boot control block, it contains the code in order to boot the operating system. So the main thing about the boot control block, it contains the information which is needed to boot an operating system. When coming into the volume control block, it specifies the information about how many blocks are there. So what is the information and what is the data which is present in this particular structure, that is known as a volume control block. So in this volume control block, it specifies the information about how many blocks are there and what is the size of the each block and how many field blocks are there. So the every block information which will be available in the volume control block. So if you take any of the block, so we know that hard disk is divided into several partitions, that each partitions we are going to call it as a boot control block. So here it specifies that volume control block, it specifies the information about how many blocks are there and what is the location and how many fields are divided into each block. So those information which will be present in this structure known as a volume control block. Coming into the directory structure, so this directory structure are mainly useful in order to organize the file. So directory means, we know that what is the definition for the directory. So these are mainly useful in order to organize the files. Okay, so the corresponding files, list of files present in the directory structure. So what the information which is present in this directory structure, this directory structures are mainly useful in order to organize the files. So we know that all the files can be organized in the directory structure. So when it is very easy for the user to access the information. So if these are useful in order to organize the file, so the corresponding file, the list of the files which is present in the directory structure. So and last structure, that is known as a file control block. So these are the structures which is present in the secondary storage. Okay, so this is the secondary storage. In the secondary storage, so there will be a boot control block and volume control block, and as well as the directory structure and as well as the file control block. So these are the different structures which is present in the secondary storage. So we know that what is a boot control block, it contains the information or it contains the code to boot, to reboot the operating system. Coming into the volume control block, it specifies the information about how many blocks are there and what is the size of the each block and how many fields of the blocks are available. And coming into the directory structure, if you may look into this directory structure, so these are mainly, it is useful in order to organize the files. Next, file control block. So if it is a file control block, it contains the information about the files, like name of the file and what are the different attributes of the file and what is the location of the file and who are all the users who has been using the file and who has created the file and who has modified the file and who are all the users can be able to delete the file and what is the different permissions. Either it can be given the group own as given the permission like read, write and execute permission as it is given to the file. So these informations, okay, so these data, these informations, it can be present in the file control block. I will repeat once again. File control block, it contains the informations about the files, okay, so it contains the information about the file like name of the file and what are the attributes of the file and location of the file and who is the owner of the file and when the file is created and when the file is been modified and when the file has been deleted and overall the group owner and the other permissions like and what is the permission like the read permission is given to whom and write permission is given to whom and also the execute permission is it given in the any of the members which belonging to the particular group or not. Okay, so these informations if the user has to required these all the data and these are the information which is present in the file control block. Okay, so this about the on disk structure. So what is the information which is present in the boot control block? Is what the information which is present in the boot control block? Which are you people have today afternoon?
DC, ma'am.
DC. Okay. Yes, tell me what is the information which is present in the boot control block? Okay, what's the information which is present in the file control block? Are you people are getting the concept or no? Is it can you able to clear the concept?
It contains file permission, ownership.
Yes, good. It contains the file permissions and also it contains the name of the file and what are all the attributes of the file and location. So, etc. The information which is related to the file can be present in the file control block. So, in the same manner, what is the information which is contained in the boot control block?
The information needed to boot an operating
Yes,
system.
good. So it contains the information which is needed to boot an operating system. It can be present in this boot control block. Okay, so that is all about the on disk structure. So in the file system implementation, we have seen the two different structures. In order to implement the any file system, we have to use the two different types of structure. One is the on disk structure and second one is the in memory structure. Okay, so in on disk structure, these are the different structures which is present in the secondary storage devices like so what is the code to boot the operating system and what is the volume control block and how the files are organized in the directory and what is the location of the file and the attributes of the file. So these are the informations which is present in the secondary storage device. When coming into this memory structure, so in memory structure, so these are the structures which is present in the main memory. So this second block we are going to call it as a main memory. So what are all the different structures which is present in the main memory? First one is the in memory mount table, in memory directory structure, system wide open file table, per process open file table. So these are the four different types of the structures which is present in the main memory. So in this memory structure, so in memory mount table, so first one is the memory mount table. So it contains the information about mounting. Okay, so what is the information it contain? It contains the information about mounting, and what is the mounting point, and which location the corresponding directory we has to be attached. So here the name itself indicates mounting. So what is the meaning of the mounting? We have already discussed it. Like it is, we want to attach or we can detach the directories. So for example, two different files, two different directories can be located, so at single point, at some point which is known as a mounting point. So in that mounting point, so it specifies the location at which the file system is attached. So at particular point where if you want to attach the file system, that point we are going to call it as a mounting point. So what is the information or what is the data which is present in this mounting table? It contains the information about the mounting and what is the mounting point and which location we have to attach the other directory. So mounting is nothing but the attaching the directory structures to the one file system. Okay, so this is about the memory mount table. Okay, so these are the structures which is present in the main memory. So now second one is the in memory directory structure. So let we have 100 directories in a secondary storage. So out of 100, if we want to access the 5 directory, so recently that information will be placed in the memory directory structure. So let me take an example. There will be 100 different files, 100 different directories are already present in the secondary storage device. So I am the user, I need only just 5 highlighted directories. Okay, so once one a time if I visited and I already seen that 5 different directory structure, so then at the next time if I visited the same place and if I need to get the same directory, so then these information like whatever the directories which is used by the user recently, so out of the 100, 5 different directories which is used by the user recently, so that information, that directories, it can be present in the memory direction structure. So I will repeat once again, what is the information which is present in the memory directory structure. So for example, there will be 100 different directory structures are there. If you take the 100 directory structures, so in that any 5 different structures if I need to access. So if I already accessed the 5 different structures, the same structure I need to get at this another time, then no need to search or no need to look into all the 100 directories. Okay, so 5 which is I've already used, which is recently used by me, is present in the memory directory structure. And next is the system wide open table. So here in the system wide open table, here the name itself tells that the system means here the file table, it is belonging to the entire computer, like whatever the table, file table, it is maintaining in the memory structure. So that file table, it can be belonging to the entire computer. Okay, it contains files that are opened by the several processor. So it contains the different files. Okay, so that files that are opened by the several processor. So all the, let me take 100 different processor. Okay, so that corresponding 100 different processor files or all the information can be available in this structure that is known as a system wide open file structure here. And coming into the per process open file table, it contains the information about the single process. So the name itself indicates it is a per process. Here it is a system wide process. So in this system wide open file table process, it contains the information about all the processor which is present in the computer. But when coming into the per process open file table, it contains only the single process information. So the difference between these two is that only here the per process, like only the single information which is present here. When coming into the system wide open file table, it contains the entire information, like entire different processor information which will be present in the system wide open file table. So this is about the two different structures for implementing the file. One is the on disk structure and second one is the in memory structure. Okay, so if you look into this is a diagram for the in memory file system structure. So that is what in memory file system structure. Here first one, it is the system call for the open a file, and second one it is for the read a file. If you look into this, it is the two different user space here to open a file. So at any point of time, if you want to open the file, then you have to know the name of the file, right? Open file name. So for example, I given like a1.txt, then I need to open that particular file, that is known as a a1.txt file can be opened. So whatever the file you have opened there, so that particular file, it will going to check whether it is present in the directory structure or not. We know that if the file is open, if that corresponding file, if it is present in the directory structure or not. So if it is present in the directory structure, so it will look into this here, it is a directory structure, like a1.txt, it is present in the directory structure. So if it is present in the directory structure, then what you have to do, you have to know the file block, file control block. So like for if you are taken the a1.txt, that is the file which is present in the directory, then if it is present, then you have to know the location, right? Then you have to know the location of that particular file, and also you have to know the file control block, like what is that name of the file is already known, and what are the attributes of the file, and what are the operations of the file, and who has created the file, and who has modified the file. Okay, so these informations, it can be stored or it can be get by using the file control block. Okay, so what is present in the secondary storage. So this is about how the file system memory, it can be implemented by using the open a file. So next, if you want to read the file, okay, so if you want to read the file, then you want to know that where that particular file has been located, and also the what is the name of the file. Okay, so you have calling the system call, that is known as a read. So this read system call, it can points to the two different structures. So here this first one, we are going to call it as an per process open file table, and the second one we are going to call it as an system wide open file table. We have already know the difference and definition between this per process open file and as well as the system wide open table. In the system wide open file table, it contains all the information about the all the process which is present in the system. But in the per process open table, in this per process open table, it contains only the information which is related to single process. Here I need to read only the single process. Now I am pointing this index, now I am pointing index to the per process. Okay, so for example, here I am reading b1.txt file. So that b1.txt file, thus corresponding to this per process open file table, like where the file has been located and what is the value of that file, that entire information which is present in this per process open file table. If that particular process table, if it is present here, then again it will make a block to the system wide open table. So in that system wide open table, so if you want to read the b1.txt, then you have to look into the different data blocks. So here what is the different data block? So it will contains the information, like all the information about the file, it can be present or it can be loaded in the data block. And next again the file control block. So again the same thing like the secondary storage structure, the file control block, it is nothing but the different values, like what is the name of the file and what is the attributes of the file and how the file has been created. Okay, so these are the informations which is present in the secondary storage. Okay, so this is how we are going to calling the two different functions to open the file and as well as to read a file. So here we have taken the two different file calls. Okay, so that completes about the file system implementation. Okay, so next we have to study the directory implementation. So before moving on to the directory implementation, so I will tell this once again. In this file system implementation, we have taken the two different types of approaches. One is the on disk structure and second one is the in memory structure. Okay, so in this on disk structure, so these are the different structures which is present in the secondary storage, and in memory structure, these are the different types of the structures which is present in the main memory. Okay, and also this contains the information about how the system has been booted, the complete code which is presented there. And in the volume control block, it contains the information like how the blocks are created and how they, what is the location of the block and what is the each size of the block. In the directory structures, these are mainly, it is useful in order to organize the files. Okay, so that corresponding file list of the files can be present in the directory structure. When coming into the file control block, it contains the information about the file like the name of the file and what are the attributes of the file and as well as the location of the file. It can be present in the FCB. So in coming into the in memory structure, so in the first one, that is a mount table. So there it will contain the information like the mounting and what is the mount point and which location the corresponding directory structure is attached. Coming into the memory directory structure, if you have organized the unread directories, like only the file directory information if I needed, that whatever the user has been used recently, those file structures, it can be stored in the memory directory structure. When coming into the system wide open file table, so in that system wide open file table, the name tells the system means the file table which belongs to the entire computer. So it contains the files which is opened for the several process, where the per process open file table, so this process it contains the file which is opened only for the single process. Okay, so and this is how the memory file system can be implemented by using the open file system call, and it is by using the read file system call. In this open file system call, we have, if I need to open the file, then I need to know the name of the file. If that particular name, if it is present in the directory structure, then it will going to know the location of that particular file. Okay, so if you know the location, then you are able to know the file control block, like who has created the file and who has modified the file and what are the attributes of the file and what are the permissions of the file. Okay, so these are the information which is present in the file control block. And coming into the read index, if I need to read the any of the file, so first I need to make a index like file name, it can be indexed into the per process open file table. In that per process open file table, we have already know that only the single process information is present in the per process open file table. So if the information it is present here, then again it will make a point to the system wide open file table. In the system wide file table, so the information or the data, it can be present for all the system. So then you can know the again the which is the file I need to read and what are the attributes which is added to the file. Okay, so these are the information I can be taken by using this file system structure. Okay, so the next topic is the